So all of these words mean the same things. We talk about the zeros, the roots, the x-intercepts, the factors, and the solutions. That doesn't much look like an L, but that is an L. All of these words are all talking about where does it cross the x-axis, right? So this point is at -6. So that's my 0. I have a 0 at 0, and I have a 0 at +8. I have a root at -6, a root at 0, a root at 8. So we have all these different places where it's either touching or crossing the x-axis. In terms of talking about multiplicity, guys, in terms of talking about multiplicity, we're going to look just around, right around the root or the 0. So if I ignore all of this function, oops, I'm touching it, that's not good. If I only look at this function right around where the root is, just ignore the rest of it for a minute. What does that look like? Okay, please stop talking.
A vertical line.
It looks like a vertical line or a nearly vertical line. In any case, it looks like a line. And a line is linear, right?
Yes.
So this one looks linear. It looks linear. That's supposed to be an L. It looks linear. If it on the paper that I gave you, they say it's crossing the x-axis. They call this a cross. So sometimes you'll see it's called a cross.
I thought linear always went like
Not necessarily. But the point is it just looks straight in that little small section, right? It just passes straight on through. It crosses to the other side. Usually when I teach this with my own terminology, I just say it passes through. Right? So it crosses, it passes through, it looks linear. All of those things, all of that is multiplicity equal to 1. So when it looks like this, so at -6, so I have a root at x equals -6. To make that a factor, you have to set it equal to 0 by adding the 6 to the other side. So I have a factor x plus 6, and its multiplicity is 1, which also means that its exponent is 1. Now, we don't usually write that 1, but I'm just emphasizing multiplicity 1 means the factor is just, there's just one of them. So the exponent is 1. If I look at, I forgot I had to do this. Hold on. If I look right around this one, what does that look like? If I just look at the piece of the graph inside that green circle, what does it look like? Like a negative quadratic, a negative parabola, right? So it looks quadratic. I usually say it reverses. On that paper I gave you, they called it bounce. It's a bounce, or it bounces. But it looks quadratic. So this one, I'm going to draw it down here. This one is multiplicity 2. And then when I write the factor, it's at 0, so I don't need a plus or minus 0. I would just write that factor as x squared. So the exponent is 2. Now, what does this last one sort of look like? I didn't draw it very well, but what does it sort of look like? It looks odd. What's the smallest odd one that looks like this? cubic. The point of a cubic is that it comes in with one direction, and at the root it changes to the other direction here. So all the odd degrees after 1 look like this. So I would call this one a bend. On your paper, it calls it a wiggle.
Do the wiggle.
Yep. I don't think there's another one. So the way I've drawn this one is multiplicity 3.
I'm still confused.
So when I write this factor, this is x equal to 8, right? The root or the zero is at x equal to 8. So the factor becomes x minus 8. With a multiplicity of 3, it's cubed. So if I write a general form for this equation, I have an x squared times an x plus 6 times an x minus 8 cubed. So this is a general form for this function, for this graph. Now, I say it's a general form because if we don't have any leading coefficients or anything else in there, then it probably won't match the heights here. It probably won't match those. Or, yeah, it probably won't match these. In order to get those specific values, I would have to have some other coefficients in there. And we'll get into that a little bit later. So, the degree of this function, there's 1 root on the left, 2 in the middle, and 3 on the right. So the degree of this function is 6. I'm going to move that one a little bit because it looks confusing to be there. Okay, do you understand what we just did?